Students, good morning. Really, I'm so happy to see you once again through this CETEL YouTube channel. Today's class is Virial Equation of State. Today, I'm going to provide a brief information on Virial Equation of State and how it is distinct over other equation of states. Three important points. Virial Equation of State is formed from the sound theoretical basis using kinetic theory of gases. Sound theoretical basis. It has sound theoretical basis from kinetic theory of gases. Point number 1. Point number 2, there is no arbitrary assumption. Arbitrary assumptions. Point number 3 is something more important. It accounts the intermolecular forces of attraction. Intermolecular forces of attraction and repulsion. Intermolecular forces of attraction and repulsion between the molecules of gas. Between the molecules of gas. Three salient points in Virial Equation of State. First point, it has sound theoretical basis from kinetic theory of gases. Second point, there is no unnecessary arbitrary assumptions. Third point is much more important. It accounts intermolecular forces of attraction and repulsion between the molecules of gas. Clear? Before entering into this continuation, I want to recorrect several points from the already classes. Already we discussed the PVT behavior of pure fluids. In this topic, we estimated or find the variation of molar volume of a gas with respect to pressure at constant temperature. This is the graph A, B, D, E. We already discussed a lot more about. This is saturated liquid, this is saturated vapor, this is superheated vapor. More information we already discussed. Now the point is, the line A, B, D is called as isotope because the experiment is performed in a particular temperature T. So temperature is constant, the line A, B, D, E is called as isotope. Now the discussion is, this is gas or vapor. This is gas or vapor. For any gas or vapor, the product of pressure and volume in this isotome, along the isotome, the product of pressure and volume along this isotome is almost constant and is exactly equal to R into T. What I am trying to say is, for any gases or vapors, the product of pressure and volume along the isotome A, B, D, E is almost constant and is equal to R into T. This is the main information. The product of pressure and volume is almost constant and equal to R into T along the isotome A, B, D, E. This information suggests the possibility of formation of Virial Equation of State. That means P divided by R into T, the ratio of PV divided by RT, that is equal to V divided by R T divided by P. Again, this is V. This is volume of real gas. This is volume of gas if it behaves ideally at the stated temperature and pressure. This is actual volume, ACTUAL, actual volume. This is volume under ideal condition. Volume under ideal condition. Ideal condition. Or you can say that volume of gas, if it behaves ideally at the stated temperature and pressure. So PV by RT is equal to volume divided by volume. Volume of, this is the ratio of volume of actual gas divided by volume of gas if it behaves ideally under stated temperature and pressure. This ratio is called as compressibility factor. Compressibility factor. The notation for compressibility factor is Z. So Z is equal to PV by RT. This is the Virial equation of state. This information suggests to provide the Virial equation of state in terms of power series, either in terms of pressure or in terms of volume. So PV by RT is equal to 1 plus B divided by V plus C divided by V square plus D divided by V cube and so on. Similarly, 1 plus pressure V prime divided by P prime into P plus C prime into P square plus D prime into P cube and so on. Clear? This is the power series equation. This equation is called as Virial equation of state, where B and B prime, C and C prime, D and D prime, these are all Virial coefficients. Virial coefficients. This is only the function of temperature. This is function of temperature only. This is depends only on temperature. This is a brief information on Virial equation of state. B and B prime is called as second Virial coefficient. B and B prime is called as second Virial coefficient. Second Virial coefficient. This is used to account the deviation from ideal behavior which results from intermolecular forces of attraction and repulsion between two gaseous molecules. Second Virial coefficient takes into account the deviation from ideal behavior which results from intermolecular forces of attraction and repulsion between two gaseous molecules. Two molecules. C and C prime, third Virial coefficient. C and C prime are third Virial coefficients. This is taken into account the deviation from ideal behavior which results from intermolecular forces of attraction and repulsion between three molecules. Similarly, D and D prime, intermolecular forces of attraction and repulsion between four molecules and so on. You can truncate with the second Virial coefficient. You no need to account the third and fourth because it does not cause serious error. Because up to second Virial coefficient you can get accurate result, molar volume of gas accurately by using Virial equation of state. This is brief information regarding Virial equation of state. Thank you.